Hello, teachers, and welcome to our overview of the Relationships to 99 Curriculum Guide. A link to this document, along with links to all other curriculum guides, can be found within the corresponding instructional unit in CMS. To begin our overview, notice the blue links embedded throughout the document. These links will redirect you to other locations within the document, websites, videos, and other resources. By clicking the link in the title of the unit, you will be redirected to the corresponding digital resources page. Notice in the links embedded within the table of contents that Big Idea 1 and 2 are separate. This is different than previous units. After each big idea, you will find vertical alignment, teacher clarification and notes, misconceptions, instructional strategies, and resources. The unit assessment is located near the end of the document and covers both big ideas. Let's click Big Idea 1 and take a look. These are the big ideas and essential questions that were located previously in the KUDs. They are followed by the texts and corresponding student skills. Sometimes we refer to these as the do's and no's. What is this student expected to do, and what do they need to know to be able to do it? These will be a part of your unpacking the text when you plan conceptually. The texts and skills are followed by the vertical alignment section. The vertical alignment section is intended to provide you with information regarding prerequisite skills and what the skills you are teaching build to in subsequent grade levels. The vertical alignment is followed by the teacher clarification and notes section. This is normally the largest part of the document, as it gives a great deal of instructional guidance on how to approach topics with students. The information within the teacher clarification and notes section is similar to what was once found in the unit at a glance, but has been updated and expanded upon. At the end of each big idea, you will find the resources section. It is important to note that this guide has two resource sections, one after each big idea. The links embedded within the table of contents at the top of the document will take you directly to each section if you are having trouble finding them. Within the resources section, you will find the Pearson and Vision lessons that are aligned to the text outlined in the guide located on the left side. On the right side of the resources section, you will find the other suggested resources that may also be used. A link to these resources can be found in the instructional unit in CMS titled NISD Resources Relationships to 99. We give a detailed overview of each of these resources after the overview of this guide. At the end of the guide, you will find two end-of-unit assessments. One is a standard pencil paper assessment, while the other is a digital version that can be assigned through Google Classroom. Even though the assessments are located at the end of the document, sometimes it is a good idea to begin with the end in mind and review the assessment prior to mapping out the unit. Please continue watching as we give a detailed explanation of each suggested resource.
This is the beaded number line activity. This activity will be targeting 1.2b. Use concrete and pictorial models to compose and decompose numbers in more than one way as so many tens and so many ones. It will also be targeting 1.2c. Use objects, pictures, and expanded and standard forms to represent numbers. To create a beaded number line, all you will need is some lacing string, 50 beads of one color, and 50 beads of another color. You would begin by tying a knot on one end of the string. String 10 beads of one color until you reach the knot, and then 10 beads of another color. Continue alternating colors in groups of 10 until you have strung 100 beads. To secure all of the beads, simply tie a knot at the other end. Once students have created their beaded number lines, have them compose several different numbers from 0 to 99. Now the goal is to have them be able to compose them without counting each individual bead. You want them to be able to see the groups of 10. So for example, if I ask students to compose 23 I want to see that they can quickly see 20 and then 3 more beads. They would separate the beads like this so that you can see the value of 23. There are several other tasks you can have students do with their beaded number lines. For example, I can ask them to find 30 and count by tens. 10, 20, 30. I can also have them find 50 and count back by tens. 10, 20, 30, 40, 50. And now I need to count back by tens. 50, 40, 30, 20, 10, 0. I can also have them find a number, such as 37, and then tell me how many tens and ones are in that number. So let's find 37. 10, 20, 30, 1, 2, 3, 4, 5, 6, 7. I found 37, and I see that 37 is composed of 1, 2, 3 tens, and 7 ones. Another task you can have students do is find a particular number, such as 48, 10, 20, 30, 40, 1, 2, 3, 4, 5, 6, 7, 8. I found 48. And then ask them, is 48 closer to 50 or 40? Now, all of these activities can be recorded on a beaded number line recording sheet, such as that last example. I had asked the students to find 48, 10, 20, 30, 40, 1, 2, 3, 4, 5, 6, 7, 8. So they found 48. And then they have to tell me if 48 is closer to 50 or 40. Using this visual aid, I can see that 48 is closer to 50. This activity will be targeting 1.2b. Use concrete and pictorial models to compose and decompose numbers in more than one way, as so many tens and so many ones. It will also be targeting 1.2c. Use objects, pictures, and expanded and standard forms to represent numbers. Bean sticks are a way to connect unitizing to base 10 blocks and can be used interchangeably. Physical models for base 10 concepts help students develop the idea of a 10 as both a single entity and as a set of 10 units. To create bean sticks, all you will need are some beans, some jumbo craft sticks, and some liquid glue. Begin by having students place 10 small dots onto a craft stick. Then have them place each individual bean onto the craft stick. Once the glue has dried and your students have created several bean sticks, do several activities with your students where they are composing different numbers from 0 to 99. For example, if I want my students to compose 35, they should be able to show me 3 bean sticks and 5 individual beans. Have them record what they just did on their Full of Beans recording sheet. The number I asked them to compose was 35. 35 is composed of 3 10s and 5 1s. This activity is called Race to 99. This activity will be targeting 1.2b. Use concrete and pictorial models to compose and decompose numbers in more than one way as so many 10s and so many 1s. It will also be targeting 1.2c. Use objects, pictures, and expanded and standard forms to represent numbers. Prior to playing the game Race to 99, you'll want to introduce your students to place value blocks. A good way to do this is to compare something that they already know, which is the Unifix cube, to something that they're learning about, which is the place value block. A question you can ask is, how is a place value unit similar to a Unifix cube? How are they different? How is a 10 long similar to a tower of 10 Unifix cubes? How are they different? You can also ask, what is the relationship between the 1s and the 10s? After students have had plenty of opportunity to explore their place value blocks, you'll want to introduce the game Race to 99. For this game, each player will need their own place value chart. They'll also need their own set of place value blocks. Here I have 9 10 longs and 15 units. They'll also need a pair of dice. Once students have decided who will go first, player 1 will roll their dice. I see 2 and 1. What I'm going to do is add my two numbers to find my sum. 2 plus 1 equals 3. That's the total number of units I'm going to place in my 1s column of my place value chart. Now it's player 2's turn. Player 2 rolled a 3 and a 5. 3 plus 5 equals 8. That's how many units I will place in my 1s column. Now it's player 1's turn again. Player 1 rolled a 2 and a 2. 2 plus 2 equals 4. I'm going to add 4 more units to my 1's column. Play goes back to player 2. Player 2 has rolled a 1 and a 3. 1 plus 3 equals 4. I'm going to place that many units in my 1's column. Now I'm going to ask myself, do I have enough 1s in my 1's column to trade for a 10 long? Let's find out. I have 4, 8, 12. So I'm going to trade 10 1s for 1 10 long. Now it's player 1's turn again. Play will continue until the first player reaches 99.
This is the greater than, less than activity. This activity will be targeting 1.2d, generate a number that is greater than or less than a given whole number. Provide students with the greater than, less than work mat and the greater than, less than student sheet, along with some base 10 blocks. Model a number such as 33 with your base 10 blocks. Students will now generate a number that is less than 33 using their base 10 blocks. So we'll do 21. Students will then model a number that is greater than 33 using base 10 blocks on their work mat. So we'll do 42. Model several more examples using the base 10 blocks and work mat. On their greater than, less than student sheet, students will see a given number. Here we have 45. Let them build that on their work mat. Students will then generate a number that is less than 45 and write it on their student sheet. So we'll do 32. Students will then generate a number that is greater than the given number of 45 on their work mat and write it on their student sheet. So we'll do 53. Allow students to complete their student sheet on their own using the base 10 blocks and work mat if they need it. This activity is the what number could I be activity. This activity will be targeting 1.2D, generate a number that is greater than or less than a given whole number. Provide students with a hundreds chart. Indicate the number 25 by either circling it or placing a transparent counter on top of it. Model generating a number that is less than 25 by circling or placing another transparent counter over the number. Model generating a number that is greater than 25 by circling or placing a transparent counter over that number. Model several more examples. So, my number is 36. A number less than 36 is 24. A number greater than 36 is 49. Pose the following situation to students. I am a number greater than 40, but less than 45. What number could I be? I'm going to place my transparent counter on 40. I'm going to place another transparent counter on 55. Allow students to use their hundreds chart and discuss as many possibilities as there could be. You can show all the possibilities with a highlighter or with colored counters. Model several more situations and discuss the numbers that fall into that category. Discuss the solutions with the students. Allow them to model and discuss their findings.
This is the comparing quantities using base 10 blocks activity. The activity will be targeting 1.2E, use place value to compare whole numbers using comparative language. For this activity, you'll need 2 place value charts. You'll need the Topic 10 interactive math story, The Store Needs More, and you'll need some base 10 blocks. As the story is read, stop after each page, allowing students to compose the 2 quantities that are to be compared using base 10 blocks and place value charts. So let's begin our story. The store needs more. Oh no, I have 28 jars and 25 lids. I need more lids. 28 is more than. So I begin to compose my 2 quantities. 10, 20. Eight and 10, 20, 5. Students use the concept of place value to compare the 2 quantities. Before making a comparison, look at the greatest place value of each quantity. Students compare the 2 quantities, determining which has more or less and which quantity is greater than or less than the other quantity. So when I look at 28 as compared to 25, I'll start in the greatest place value of each quantity, and I notice that 28 has 2 tens and 25 has 2 tens, so I'll proceed to the ones place. And I notice that 28 has 8 ones, 25 only has 5 ones, therefore 28 is more than 25. Students will continue comparing quantities from each page of the story. Once you've completed that story, you can use a place value die with the digits 0 to 9 on it to generate quantities. I rolled a 4 and I rolled a 0. I can generate the number 40 or 4. For now, I'm going to generate 40. It's composed of 1, 2, 3, 4 tens and 0 ones. I'll generate another number, 5, 8. I can either make 85 or 58. I'm going to create or compose the number 58. And then I get ready to compare my quantities. If I start with the greatest place value of each number, I'll notice that 40 has 4 tens, 58 has 5 tens, therefore 58 is more than 40. This is the comparing quantities using base 10 blocks and comparative language activity. The activity will be targeting 1.2e, use place value to compare whole numbers using comparative language. For this activity, we need some base 10 blocks, we need some comparative language cards, we need a greater than, less than, or equal to recording sheet, we need a roll and compare recording sheet, and we need a spinner with the digits 0 through 9. We begin by presenting a real-world scenario in which two quantities are going to be compared. For example, Alex has 70 pennies in his piggy bank. Alton has 84 pennies in his piggy bank. Using these base 10 blocks, using a pictorial representation, and using a place value chart, we compose the two quantities that are going to be compared. Then we model how to complete a sentence using the words is greater than, is less than, or is equal to. We'll put these words between the two quantities to make a true statement. So, Alex has 10, 20, 30, 40, 50, 60, 70 pennies. Alton has 10, 20, 30, 40, 50, 60, 70, 80, 81, 82, 83, 84 pennies. 70 is composed of 7 tens and 0 ones. 84 is composed of 8 tens and 4 ones. So as we begin to make a comparison using comparative language, we can see that 70 is less than 84. Share several more scenarios where students can model and compare quantities. Once students have an understanding of the quantities and the comparisons using the base 10 blocks, we can move on to the roll and compare, where students, using a spinner, generate numbers. I spun a 1 and I spun a 4. I can make a 14 or a 41. I'm going to start with 14. I'm going to generate another number, a 2 and a 1, a 21. And by looking at the value of the 1 and the value of the 2 in the tens place, I know that 21 has one more 10 than 14. 14 then must be less than 21. This is the comparing quantities using symbols activity. The activity will be targeting 1.2e, use place value to compare whole numbers using comparative language, and 1.2g, represent the comparison of two numbers to 100 using the symbols greater than, less than, or equal to. For this particular activity, you might want to use Mr. Alligator, which is a simple way to introduce the greater than and less than symbols. You need some symbol cards. You'll notice I have symbol cards with an alligator and symbol cards without an alligator, as well as a recording sheet. For this demonstration, I'm going to use the symbol cards without the alligator. You'll also need a roll and compare using symbols recording sheet and a spinner with the digits 0 to 9. So we simply introduce the concept of greater than, less than, and equal to using Mr. Alligator, who likes to eat larger quantities. So we're going to start by showing two numbers, 26 and 14. And we're going to have a brief discussion over which quantity Mr. Alligator would want to eat. Ultimately, students need to know the meaning behind the symbols and not just what the alligator wants to eat. So if we look at our two quantities, we realize that 26 has 2 10s and 14 only has 1 10. Therefore, we begin to introduce these symbols with meaning. This meaning 26 is greater than 14. This meaning 26 is less than 14. And this meaning 26 is equal to 14. Once we've made our decision and justified our response, we can then proceed to write that comparison using comparative language. 26 is greater than 14. Once students understand the meaning behind the symbols, we then proceed to the student recording sheet where they can practice several of these comparisons on their own. Roll and compare is an extension where we actually spin a quantity. We create a 2-digit number. I spun a 9 and I spun a 1. I can create the number 91 or 19. I spun a 2 and I spun a 4. I'm going to create the number 42. I choose the correct symbol and then I make a comparison. 19 is less than 42.
The next activity is entitled Comparing on a Hundreds Chart. This activity addresses the standard 1.2G, in which students are expected to represent the comparison of two numbers to 100 using the symbols greater than, less than, or equal to. For this activity, you will need a hundreds chart as well as counters. You will begin by posing a scenario and question such as, Hayden thinks 7 10s and 5 1s is less than 57. Julia thinks 7 10s and 5 1s is greater than 57. Who is correct? You will then proceed to model your thinking using the hundreds chart and counters. For example, your think aloud could sound like this. I'm first going to use the hundreds chart to find the number 57. I know that in 57 there are 7 1s, so I will find 7 1s. I'm then going to jump down 5 10s because there are 5 10s in 57. 1, 2, 3, 4, 5. I landed on 57. I'm going to cover that up with my counter. I'm then going to find the number that has 7 10s and 5 1s. To do that, I'm going to go over to my 10s and I'm going to jump down 7 10s. 1, 2, 3, 4, 5, 6, 7 10s. This number has 5 1s, so I'm going to count by 1s 5 times. 1, 2, 3, 4, 5. I landed on the number 75. I'm going to cover that up with my other counter. These are the two numbers I'm going to be comparing. In my scenario, Hayden says that 7 10s and 5 1s is less than 57. So 7 10s and 5 1s, or 75, is less than 57 according to Hayden. I'm going to write an H for Hayden. And Julia says that 7 10s and 5 1s is greater than 57. Who is correct, Hayden or Julia? When I look back at my hundreds chart, I can see that 75 is greater than 57. And I know that because it's further down my hundreds chart, and as I go down my hundreds chart, my numbers grow in size or get greater or larger. More specifically, I know that because 7 tens is more than 5 tens. If I jump down 2 more tens, 1, 2, I'm almost to 75. This is quite a bit bigger than 57. I could also bring out place value blocks to reinforce that understanding that 7 tens is greater than 5 tens. You will continue this process with different numbers and scenarios and have students share their thinking using comparative language and symbols.
This is the Ordering Numbers Using Number Paths activity. The activity will be targeting 1.2F, order whole numbers using place value and open number lines. Students begin ordering numbers by creating a human number path and using the large number cards. After creating the human number path and introducing students to ordering numbers, teacher will display the 2-color 100 chart and relate that 100 chart to a number path. Teacher will show the students the relationship between a 100 chart and number path by cutting the first 2 rows of the 100 chart and laying them next to each other to create a number path. We can use a number path to help us order numbers. Let's look at this scenario. Sarah, Tim, and Juan played basketball this week. Sarah played 11 times, Juan played 18 times, and Tim played 8 times. Draw a representation of the 3 or 4 numbers in the scenario, find the numbers on the number path, and write the numbers in order from least to greatest. What do I know? Sarah played 11 times. Juan played 18 times. And Tim played 8 times. Let's draw a representation of these numbers. 11 has 1 10 and 1 1. Juan played 18 times, 1 10, and 8 ones. Tim played 8 times. There are no 10s and 8 ones. Let's find the numbers on the number path. Sarah played 11 times. Juan played 18 times. And Tim played 8 times. I know on a number path that my numbers go from numbers that are smaller to numbers that are greater. Tim played 8 times. That is less than Sarah, who played 11 times, and Juan had the greatest number with 18 times. I've now ordered my numbers from least to greatest. Continue using different scenarios and numbers. As an extension, you can create a number path on the floor so that students can utilize when comparing and ordering numbers. This activity is number paths to number lines. The activity will be targeting 1.2F, order whole numbers using place value and number lines. We're going to first begin by creating a number line by taping a number path onto the board and then drawing a number line underneath. Drawing a number line underneath. Using the number path, draw tick marks on the number line and relate the position of the tick marks to the number path. Discuss how the tick marks are at the end of each square on the number path. Explain that the arrows on the end of the number line indicate that the line actually goes on forever in each direction. Fill in the numbers beneath each tick mark, emphasizing each tick mark lines up with the end of the square on the number path. Notice I go one whole square, draw my tick mark, and write my 1. I go another square, draw my tick mark, and write my 2, and so on. Remove the number path so that only the number line can be seen. Model for students how a number line can be used to show groups of 10 or decade numbers. Use a large piece of butcher paper and each row of 10 from the hundreds chart. Tape each row sequentially in a continuous horizontal line. This is what it might look like in your classroom. Here's your butcher paper. Here's your number chart cut up to show your number path. And then you have your number line. Label each group of 10 with the corresponding decade number. Here's my group of 10. Here's my number, ends at my number path, and number 10 on my number line. You can use the number line to also show numbers between tens. 10. Here's my 2 10s, 60 and 70. And the number line is show between tens. You also want to model that the number line can be shown vertically. Now students can begin using a number line with the tick marks labeled, but if necessary, go back to the number path.
This is the ordering numbers using number lines activity. This activity addresses 1.2F, order whole numbers using place value and open number lines. To start, present students with a number line such as this one. Show students 3 number cards. Ask students where they think the numbers should be placed on the number line. Model placing the numbers on the number line as shown. Ask students what they notice about the numbers on the number line, leading them to realize the numbers are in order from least to greatest. Show students another number line, such as this one. Present students with 3 more number cards. Ask students to order the numbers on the number line. Discuss their suggestions and then model the solution as shown. Ask students what they notice, again leading them to realize the numbers are in order from least to greatest. Model several more examples of ordering numbers on a number line from least to greatest and greatest to least.
The next activity is titled Clothespin Number Line. This activity addresses the standard 1.2F, where students are expected to order whole numbers up to 120 using place value and open number lines. We will specifically be working within 99, as this is the relationships to 99 unit. You will start out by plucking out several cards from your number card pile, ideally 3. Okay, these are the 3 numbers that I pulled out, and you'll want to think aloud how to order these on the number line. And you want to ensure that you're using that place value understanding to place them in order from least to greatest, starting with the smallest number and building to the largest number. So in order to order numbers, you first have to compare them. So I'm just going to pull out 2 of my numbers and compare them to see which one's bigger. So when I'm looking at these two numbers, I know that in 71 there are 7 tens, and in 24 there are 2 tens. So 24 is smaller or less than 71. So I know this one will become before 71. So now I'm going to compare 71 to this number, which is 43. I know again that there are 7 tens in 71, and in 43 there are 4 tens. 4 tens is less than 7 tens, so this will come before 71. And let me double check to make sure 24 is smaller. I know that 2 tens is less than 4 tens, so 24 will come first. So this is my order: 24, then 43, then 71. I'm going to clip these onto my number line. And then you can ask students some of the suggested questions that are listed on the activity sheet. One thing to notice is that the spacing between each number is equal, and that's okay in first grade. We don't really move to the magnitude of the number until we reach second grade. So, ideally this would be further down the number line, but that's not something that we need to focus on at this time. You'll then want to record the order on your whiteboard and show students how we can transfer that to another picture representation. 24, then 43, and then 71. Continue doing several examples with your students with different cards, and give the cards to different students and have them come up to the number line and place it on the number line. Have them stand beside their number after they place it, and then ask them some questions such as, how did you determine to place the number in that order? Or between what 2 tens is your number? And so on. There are more suggestions on the activity sheet.